In the beginning was a line, and the line probably looked something like this. And now you're sitting in fourth period thinking, wow, my calculus final is on Friday. This is totally not a reason to panic. But for the next couple of minutes, I would like you to sit back and relax because I'm about to teach you something really easy, sketching derivatives. Graphs come in many shapes and sizes. Sometimes they're simple like f of x equals x, or a little harder like f of x equals x squared. And sometimes they're just really confusing like f of x equals sine of x, and really I'm not sure how exactly trig functions even work. I think it has something to do with triangles. At this point, all of you are familiar with derivatives, which are basically Google for a graph slope. You put in x and out pops the slope at that specific point in space. This is really simple if you have a graph like this, where you know that the formula is x minus 4 squared, which means that f prime is 2x minus 8. Then you can make a nice little table, and you can plot some points, and you end up with a graph that looks kind of like this. But what do you do if you don't have the formula? How do you get from the function graph to the derivative graph? Fortunately, it's pretty easy. Let's say that you have a mysterious trig function. You have no idea what the function is, so obviously you have no idea what the equation for the derivative is either. Since the derivative tells you specific slope values, our derivative will have positive y values if there's a positive slope and negative where there's a negative slope. You also know that a derivative equals 0 wherever there's a maximum or minimum, so if you mark those on the graph and you connect them using your awesome knowledge of slopes. Of course, things do get more complicated when things like absolute values start showing up, but otherwise it's easy. So long as you don't think too much about integrals.